automates the deployment, management, and scaling of containerization application. It was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. Guys, Kubernetes provides a framework for managing containers across the multiple hosts and automating the tasks like deployment, scaling, health check, managing the networking between container, managing the resource used by container, managing the storage resources used by container, and so more. Kubernetes can help organization to increase the developer productivity. That means the developer can focus on writing code and not worry about the underlying infrastructure. Guys, to improve the application scalability. Application can be scaled up or down quickly, easy to meet demand. Guys, Kubernetes can automate many of the tasks that would otherwise need to be done manually, reducing the need for human intervention. Kubernetes can automatically restart failed container and reschedule them to healthy node. Kubernetes can automatically scale the number of containers up or down based on demand. Kubernetes can automatically distribute traffic across the multiple containers. Now guys, I'll give some idea about what is cluster and nodes. As you can see here, cluster are the groups of nodes. A cluster is a group of interconnected computer or virtual machine that work together as a single system to provide a high availability, scalability, and performance. Guys, each computer or virtual machine in the cluster is called a node. A node is a single computer or virtual machine that is the part of a cluster. Each node in a cluster has its own CPU, memory, and storage. The nodes in a cluster work together to run application and provide services. The nodes in a cluster communicate with each other using a network and coordinate there using the specialized software. Clusters are often used to run applications that require a lot of computing power that need to be highly available. In Kubernetes, nodes are the worker machine that runs containerized application. Each node has a kubelet, which is an agent that communicates with the Kubernetes control plane. The kubelet is responsible for managing the containers on the node and reporting the node's status of the control plane. Guys, what is pod? In Kubernetes, a pod is the smallest deployable unit that can be created and managed. Pod represents a group of one or more containers that are tightly coupled and share the same resources and context. Tightly coupled means components directly interact with each other and share the internal details, leading to a high degree of interdependence. Tightly coupling refers to a situation where two or more software components are highly dependent on each other and have a strong interdependency. I hope now guys you understand what is tightly coupled. Guys, pods are basic building blocks of Kubernetes application and they are typically used to encapsulate a single microservices or component of an application. Pods are the unit of scaling in Kubernetes. The number of replicas of pod can be adjusted based on demand, allowing for horizontal scaling of application. Pods provide a logical grouping for containers that are tightly coupled and need to share resources and context. This simplifies deployment and management. Example of pod uses in a web application. A pod might contain a web server container and a database container, allowing them to communicate efficiently and share resources. You know guys, what is deployment? In Kubernetes, a deployment is a declarative way to manage the lifecycle of pods and replica set. It describes a desired state of an application, including the number of replicas, the container image to use, and the resources to allocate. Kubernetes will then ensure that the actual state of application matches the desired state. Deployment are most common way to manage the stateless application in Kubernetes. In Kubernetes guys, the stateless applications are those that do not store data or application state on the cluster or a persistent storage. They handle each request independently without relying on data from previous requests. Stateless applications are typically easier to scale and manage Kubernetes as they can be replicated and distributed across multiple nodes without concern about data consistency or synchronization. Basically guys, the deployment are defined using YML or JSON file, which makes them easy to manage and version control. Deployment can be used to perform rolling updates, which means the new pods are created and old pods are terminated one at a time without downtime. If deployment fails, it can be rolled back to the previous version. Deployment can be scaled up or down by changing the number of replicas based on the project requirement. To create a deployment, you first need to create a YML file that describes a desired state of the application. This file will include the information such as container image to use, the number of replicas, and the resources to allocate. Once you have created the file, you can apply it to the cluster using the kubectl apply command to create a deployment based on your requirement. Guys, I'll show you all the details in the lab so that you can easily understand it. Now guys, I hope so you can understand what is Kubernetes, what is cluster and node. Cluster are the groups of nodes, and guys, what is pods and what is deployment. This is the important component guys in Kubernetes. Guys, what is GKE? Guys, as you can see here, GKE is a managed Kubernetes service that lets you deploy and manage containerized application on the Google Cloud platform. GKE allows you to deploy, manage and scale containerized application using Kubernetes without the need to manage the underlying infrastructure. GKE is a fully managed service, which means Google handles most of the operational overhead, including the control plane, cluster management and node maintenance. That means guys, Google can manage all the infrastructure part. It allows you to easily scale your application up or down by adjusting the number of nodes in your cluster or by deploying additional pods. GKE provides the automated upgrade, maintenance and redundancy to ensure the high availability of your application. GKE integrates seamlessly with other Google Cloud services like cloud logging, cloud monitoring, cloud IAM for access control and more. GKE also provides a number of features that make it easier to manage your Kubernetes cluster, like automatic provisioning and scaling of nodes, automatic upgrades and repairs, integrating logging and monitoring, security features such as pod security, policies and network policies and more. GKE provides the feature like identity and access management, role-based access control, network policies to help secure your cluster and application. GKE can automatically provision and scale nodes to meet the demands of your application. It provides a robust, reliable and scalable platform for deploying modern application using container and Kubernetes. Guys, you can manage the multiple GKE cluster across the different regions and zones from a centralized console. GKE support both horizontal port autoscaling and cluster autoscaling, allowing your application to dynamically scale based on your resource requirement. If you are considering using a Kubernetes to deploy and manage your containerized application, then GKE is a great option for you. It is fully managed service that can help you to reduce the operational overhead, increase developer productivity, and improve the scalability and security. As you can see here guys, GKE having two modes. One is autopilot mode and another is standard mode. Let's discuss more details about autopilot and standard mode in Google Kubernetes engine so that you can easily understand it, and based on your project requirement you can select it. Let's discuss autopilot mode first. GKE autopilot mode is a fully managed that automates the most of the cluster management tasks including provisioning, scaling and maintenance. This makes it a good choice for team that wants to focus on developing and deploying application rather than managing infrastructure. It means guys, you can only deploy your application inside the autopilot cluster and infrastructure is managed by Google. Autopilot provides less flexibility and control over your cluster compared to standard mode. Guys, I'll guide you in which scenario cases can you select the GKE autopilot mode for your project requirement. Firstly guys, teams that want to focus on developing and deploying application rather than managing infrastructure. Teams that are new to Kubernetes, do not have a lot of experience with cluster management. Teams that have workload and predictable resource requirement. Then guys, this is the best choice for you can go for autopilot mode because you don't have lot of experience in cluster management, so that Google can manage infrastructure part and you can only deploy your application on the autopilot cluster. Let's discuss about the standard mode. Standard modes provides more control over your cluster infrastructure, making it a good choice for teams that have a specific infrastructure requirement and want more fine-grained control over their cluster. It means guys, you have a lot of experience with cluster management, then you should go for standard mode, and I'll guide you in which scenario cases can you select the GKE standard mode for your project requirement. Guys, teams that have specific infrastructure requirement or want more fine-grained control over their cluster. Teams that have experience with Kubernetes and cluster management. Teams that have workload with variable and unpredictable resource requirement. Guys, these are the same cases. Is your team having a good experience in Kubernetes and cluster management, and your team have workload with a variable and unpredictable resource requirement, then you should go for GKE standard mode. That is the best choice for you because you have good knowledge and lot of experience about the cluster management as well as in Kubernetes. Now I will give some idea what is the basic difference between both autopilot and standard mode. First, we'll compare the both for cost optimization. Guys, in autopilot mode, you can pay only for the compute resources you're running pod requests. Autopilot pricing is based on pod usage. This means guys that autopilot can be more cost effective for workload that have predictable resource requirement, and you can only pay for based on your pod usage only. On other hand guys, in GKE standard mode, you pay for all resources on nodes regardless of pod request. This means standard mode pricing is based on the node usage. Guys, I hope so now you can understand. For the cost optimization, in autopilot mode, you can pay for as per your pod usage, but in standard mode, you pay for all resources on nodes. This means standard pricing is based on the node usage. For security wise guys, autopilot has some built-in security features that are not available in standard mode. However, standard mode gives you more control over your cluster security posture. For compliance, autopilot is not compatible with some compliance requirement. If you have a specific compliance requirement, you may need to use standard mode during the term of agreement under which Google has agreed to provide Google Cloud Platform to the customer. Guys, in the Google Kubernetes engine service level agreement, the service level agreement means the agreement in between the customer and Google as a cloud provider. Then Google Cloud provides service to the customer a monthly uptime percentage as autopilot cluster control plane has 99.95% and autopilot pods in multiple zones has 99.9%. Guys, as you can see here, some of the basic difference between autopilot and standard mode. For cluster management, in GKE autopilot mode, fully managed by Google. On other hand, GKE standard mode, more manual configuration and management required. For node provisioning, GKE autopilot mode, automatic based on workload demand, but in GKE standard mode, manually provisioned and configured. Node scaling, automatic based on workload demand, manually scaled or configured with autoscaler in GKE standard mode. For node maintenance, automatically upgrades and repairs in the GKE autopilot mode, but in GKE standard you can manually schedule upgrades and repair for your node. The control plane management, it is fully managed by Google in GKE autopilot mode, but in GKE standard mode, shared responsibility between user and Google. Flexibility and control, GKE autopilot mode is less flexibility but easier to manage, but in GKE standard mode, more flexibility but require more expertise. Guys, now I hope so you can understand what is Kubernetes, what is pods, what is deployment, what is cluster and node, and what is Google Kubernetes engine. And Google Kubernetes engine having two modes, one is GKE autopilot and GKE standard mode. And I hope so now you understand what is the basic difference between GKE autopilot mode and GKE standard mode. In which scenario cases can you use for GKE autopilot mode and in which scenario cases can you use for GKE standard mode based on your project requirement. If you are having good expertise in Kubernetes, then you should go for GKE standard mode. If you don't have any expertise skill for Kubernetes, then you should go for autopilot mode. That is the basic difference between autopilot and GKE standard mode. In GKE autopilot mode, Google responsible for all the infrastructure, but in GKE standard, you are the responsible for management for cluster and nodes. That is the basic difference between both guys. Thank you guys. I'll show you in the demo for our upcoming session how do you create a GKE autopilot cluster using GCP console and how do you create a GKE cluster using CLI command and how do you deploy a web application in GKE cluster so that you can easily understand it.